Okay, so let's get started. We're going to be taking a look at setting up and working with a Transbrake Creep feature found within our Link G5 and G4X systems. Now, Link doesn't natively support Transbrake Control and Transbrake Creep. We're going to have to get creative with our software in order to accomplish this task. It's actually quite simple to do, but there are very specific things that we need to know. We're going to be using an Excel spreadsheet calculator to understand how to set up our table and what to expect as the result. So there's a frequency and a duty cycle aspect that we have to consider in order to get proper creep feature from our Transbrake control. Now, the first thing I want to do here is talk about how we need to set things up for a Transbrake and a creep feature. There are going to be some components that we need to have wired in specifically, and then how we program those items within the calibration file here. And then we'll go through the Excel spreadsheet calculator to get a little bit more specific of getting the vehicle to creep in a fashion that we'd like. So whether it's going to be a slower creep or a faster creep, there's going to be some things that we need to know with that. All right, so the first thing we're going to do is take a look at our schematic outlining what I'm covering here in this tutorial, how to make this feature work. This is what I've done on a couple different vehicles, and it works extremely well. It's pretty simple, but very effective. So the very first thing that we're finding here is we have a button dedicated for our Transbrake. That's going to engage our Transbrake solenoid to put the automatic transmission into its lockup with the Transbrake. That's what we use to get on the Transbrake and stage our vehicle at the line, and then ultimately we let go of the button and we launch, and the Transbrake's going to release, and we're going to launch and go down the drag strip. So the Transbrake button is usually going to be found on your shifter that you press, and it's usually a momentary button. Next, we're going to have another momentary button, typically found somewhere on your steering wheel. It's a momentary style button that you're going to be pushing with your left hand. You have one hand on the shifter and then your left hand on the steering wheel, so the button should be somewhere you can reach with your thumb. Now, that button is going to be our creep feature button. Both buttons will be wired into the Link, and in my schematic here, I'm going to be sending a ground input through the buttons into either digital input that I'm going to be wiring these to for the Link. You could send 12 volt in to each button, but I usually like to keep things simple. When I'm wiring up buttons, and I usually like to use ground, just a little bit safer in case something shorts out with 12 volt. So I usually use ground. That's how I have my schematic here set up. So each button is going to be going to chassis ground. The output from the button is going to be going to digital inputs to our Link ECU. So whether it's a G4X or G5 doesn't matter. Now we're going to have an output that we're going to be assigning. That's going to be a general purpose pulse width modulated output that we're going to be sending to control a solid state relay. And that solid state relay will then be controlling your Transbrake solenoid. So the Transbrake solenoid is pretty simple. One wire is going to go to chassis ground. The other wire is going to be going to the solid state relay, and that's going to be getting 12 volt pulsed from the solid state relay. We can't directly drive or control a Transbrake solenoid with our Link G5 or G4X. There is not enough syncing amps on the output pins, so that's why we use a solid state relay. So looking at that particular solid state relay, it's going to be a Holley part number 15620NOS. This is my go-to solid state relay when I'm doing any kind of pulse width modulated control and I require a relay. So something like boost control, you can directly drive a boost control solenoid. They pull less than an amp, but anything that's going to be a sizable amp draw, we always need to have a relay. And in this case, because it's pulse width modulated, we use a solid state relay. Now the Holley relay, the Holley solid state relay, can handle up to 1000 hertz and 40 amp continuous. So it's pretty stout relay, and it works well. So that's why I always incorporate it here in the training courses, because this is my go-to my go-to relay. So taking a look at that relay, we're going to have 3 pins on it. Pin 3, that's going to be coming from our battery 12 volt. Now between the battery and the solid state relay, you will need a fusible link or a fuse of some sort. Usually 10 amps is fine. Then we're going to have our pin 2. That's what we're sending from our link here to be able to control that solid state relay. That's where we're going to be low side pulsing. So input 2 comes from the output from the link. Then pin 1 is what we send to the Transbrake solenoid. That's going to be, again, 12 volt pulsing the Transbrake solenoid when we want the creep feature to work. So a pretty simple schematic, Pretty simple in order to set this up. Now let's go in here and define a few things in our software. So we need to go and define the output and the input and see how this is all going to work. First thing we're going to do is go in here to our digital inputs, and we're going to use two general purpose inputs to account for the Transbrake switch and then the creep switch, the creep button. So let's go here to our general purpose one, and I'm going to go ahead and assign this. Double click here, and we're going to go in here and say Transbrake. So we know it's going to be assigned to the Transbrake. And the source, we have to assign it to a digital input. I'm going to choose any digital input. You could even use other options as well. You could even use CAN inputs. Now, usually what I would recommend here is not using a CAN input simply because you don't want to take your hand off the shifter. So your right hand would be on your shifter. Traditionally, the Transbrake button is going to be mounted on that shifter, so you can press it. As you're holding, it's typically a pistol grip style shifter. You're going to be holding that pistol grip and pushing the button at the same time. So I'm going to be using a digital, not a CAN, so I don't have to worry about trying to reach over and hit a CAN keypad. In this case, I'm going to be assigning this to digital 4. And then, thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.